Everyday industries generate tons of pollutants, waste that we struggle to manage, hide, or dispose of. But what if that waste isn't waste at all? What if it's the next building block of our cities? From industrial byproducts to construction materials, today we are exploring how pollution can be transformed into possibility. Hello and welcome to the Sustainability Side. I'm your host, Dr. Sama. Here in the Sustainability Side, where the conversation don't just stay as conversations, they evolve into impact, research, and the real world change. And today's episode sits right at the intersection of innovation, engineering, and sustainability. We are diving into a powerful and a timely topic, which is waste to wealth, an approach towards sustainable construction from pollutants. With rapid urbanization and increasing industrial waste, the challenge is no longer just disposal, it is transformation, how we do convert the environmental burdens into structural solutions. And just to guide us through this, we have an esteemed academician and an expert in the field, Dr. V. Murugesh, professor and head of the JCT College of Engineering and Technology. In this episode, we will explore how science, research, and engineering are redefining the waste, turning it into the sustainable construction materials, and ultimately into a big opportunity. Let's get started with a small introduction.
Sing it loud, let's unite on the sustainability side. Feel the love day and night. Let's turn the tides, make a change today. Together we define our sustainable way with every step we take. We rise and glow on the sustainability side. Let the good vibes flow.
Hello, sir. Welcome to the show.
It's a great introduction about me. First of all, my heartfelt thanks to the sustainable side and also Dr. Sama, who is the academic leader, is a founder of Shasha Global Consortium. It's a great pleasure to present my presentation regarding waste to wealth.
Yes, sir. Thank you so much. So let's get started. But to begin with, Dr. Mugesh, when we say waste to wealth, in the construction line especially, what does it truly mean in a scientific and a practical sense?
Yeah, scientifically, waste to wealth is nothing but we are just converting the hazardous waste streams to a valuable and high performance construction materials. For example, if you are using the foundry sand, it is a waste material from the industry waste, but we are replacing instead of our sand, we are replacing is 40 percentage of sand with our traditional sand. So normally the hazardous materials we are reusing and it will be becoming a most valuable materials. Next, second one is plastic waste. So we are using as a bitumen modifier in roads. So plastic is automatically recycled to the road construction. So these things, the waste is automatically converted to wealth.
What is a pickle? To some, it's just a condiment. To us, it is time captured, ancient herbal wisdom of the land, distilled in 100% pure ingredients. From the blood purifying depth of bitter gourd to the restorative strength of the pirindai stem, we bottle nature's boldest essence. This is not just pickle. This is tradition, purity. This is heritage, preserved, crafted by nature, perfected by time.
Oh, okay. Thank you. So moving ahead, I have one more question, which is like, what are the types of industrial pollutants or waste materials are currently being explored for sustainable construction, and which one shows the most promise?
Yeah, at present, fly ash is utilizing, I mean, so it is taken from the thermal power plants. Then GGBS, there is ground granulated blast furnace, it is taken from the steel industries. Then silica fumes, it is taken from the ferrosilica industries also. Then we are using the waste plastic materials for using the replacing of roads, bricks, like that we are using. But now the emerging waste material, the sustainability is preferring on biochar. That is the waste agriculture products, cow dung projects, then rice cuss ash. These are the waste materials it is easily available from the industry also, and also from the naturals also. So, so what is the thing we are using here means it is only one thing is a carbon segregation potential. We will make the environment net zero carbon by using these products.
Oh, okay. That's really awesome. I actually covered a session regarding this green concrete. In that, we talk a lot about the projects like mycelium and these kind of organic things being used. What's the difference when we organically use the green, a total green structure into the product rather than a waste converting into the material? Does it have any different life or use of both the different structure?
Ah, yes, madam. Yes, actually, when we are using our traditional construction materials, normally it will manufacturing you will get 15 percentage of carbon emission is started here. That is we are called as I say embodied carbon. Okay, while manufacturing it steel, automatically then it should be built like a building means 85 remaining 85 percentage of that is carbon emission should be occurs in the building. So while using this type of sustainable materials, the carbon materials should be captured by these materials. It is not emitting the materials; it's just capturing the materials. Automatically, it start reducing the greenhouse gas effects. So that's why we are preferring about the effects. That's why we are using the sustainable materials.
Sustainable materials. So this fly ash even does it do that rather than using the literal green plants?
Yes, brothers. Our first interesting topic, it is a needable topic in the environment is waste to wealth materials. So why I prefer the sustainable construction? The strategies adopted in the sustainable construction means first, we have to see the overview of my presentation. First, we are going to the concept of green building concept. Second, what we are using, how it will be worked. So it will be goes for the strategy. The third one is much more important in the circular economy. So in the first one, we'll slightly discuss about the that is the green building concept. Why we are using this green building concept, which is totally of healthy living environment. So everyone needs living environment. It should be very healthy. Okay. So first main our concept is green building concept. Second, we have to use the necessary strategies. Why we are using the necessary strategies? We are converting the waste reduction materials. Then the waste is converted to energy efficient design, and it will be which reduce to make a net zero impact carbons. So third one, everyone we needs economic because all our needs is we are working for the economic only. So it will very much impact directly on the circular economics because we are recycling, we are reusing, and we are reusing our resources materials to a proper one usable materials. So first, why I selected sustainable construction strategy? So because we are all well aware of 17 SDG goals are there. So out of 17 SDG goals, the main 9 SDG goals is totally focused on our green homes. That is good health and well-being. And the seventh one is the affordable and clean energy. Then decent work and economic growth. Then industry, innovation and infrastructure. Then sustainable cities and communities. The 12th one is the responsible consumption and production. The 13th one is climatic action. The 15th one is life on land. The 71 is partnership for the goals. So this 9 is totally incorporated with our topic, that is sustainable construction strategy. How it is interconnected. Without sustainable construction at present, we are facing many greenhouse gas effects. When we are incorporated this sustainable construction, we can avoid incorporated global issues like climate change, deforestation, carbon reduction, biodiversity, and acid rains. At present, now the climate is totally changing. The humidity is totally changing from plus or minus 3 degrees centigrade. Sudden the acid rain is falls on Dubai. In many occasions, many places, this is all caused due to our man-made mistakes. So to avoid these problems, we have go for the sustainable constructions. So how it happens in the construction field? Because we are extracting of raw materials for using, for example, if we are using steel or cement, we are going for lime or we are going for iron ore. So we are extracting the raw materials. Then raw materials, we are going for the manufacturing. So while manufacturing, lot of dust and also dirty and also the emission of carbon dioxide is occurs. Due to COO, there should be a law increased production of greenhouse gas should be in the construction industry. So how to avoid this greenhouse gas or carbon emission by the construction is we are saying as a valorization equation. What is mean by valorization equation? So it is the key concept used in the waste to wealth. First one is raw pollutant. We are collecting the raw pollutant and it is directly applied to the engineering. What is application means whether the raw material should be decomposed by means of mechanical or chemical or it should be decomposed by thermal. So we have to apply the our engineering concept in the raw pollutant. Then systematic catalytics we are doing. Finally, automatically the raw materials are produced. Every country depends upon much more economical in the infrastructures because nowadays the infrastructure plays a vital role in the development of any country. So this construction company takes 10%. That's why I have selected this topic, sustainable construction. Then 15% of water is consumed by while constructing a building. While constructing a building, what happened? We are utilizing a good water instead of the salty water. So 15% we are wasting the water. Then 40 percentage of electricity after construction of buildings we have to utilize the electricity. So normally 40 percentage of electricity. So these things combine and automatically 23 to 40% greenhouse gas is emitted out in our environment. So these are the reasons created by us. So for construction field, I'll say that. So first, the construction phase 17%. That is extraction, manufacturing, dust, and site operation. That means, for example, if you are going for manufacturing of steel, we have there are two types: embodied system and carbonized steels. Embodied system means we have to collecting the raw materials and we have to manufacturing the steel. So that time automatically some of the carbon emissions are getting emitted. After that, these should be transported to the site. So during this construction process, 17 percentage of the carbon emission will be happens. After this, 83 percentage it will be consumed by our utilization of building, like heating. Heating means we are using the heaters, AC, then cooling and maintenance of all the such electrical things. Due to this continuous process, 40 to 50 years, normally we are emitting 83 percentage of greenhouse gas effect. So these things should be totally we have to reduce and depleted. So this is the engineering trade. It is a framework. That is first one is mitigation. It is the initial primary impacts. It is the root cause of the environmental issues. While reducing this impact, automatically the greenhouse should be get reduced. When we miss this primary impact, it will goes for the secondary impact. That means we have to demand for the water and sanitation in the future. So these things should be adapted. That is, this should be controlled and we need to adapt it to our modern infrastructures that will extend the temperature and also the flooding. So this is the three pillars of sustainable construction industry. That is, first one is environmental, then second one is economic, then third one is socialist. So here we have to improve our air water quality. We have to reduce the water streams. I already say 15% of water we are using in the construction field. So we have to conserve the natural resources. So by this time we have to reduce the greenhouse gas emissions. Second pillar, it is economic soil rust. That is, we have to operate the equally. We have to optimize our life cycle in the economic performance. So the second one is totally based on the concept of circular economy. The third one is a social. This third one is a social. It's totally based on the aesthetic qualities. So by creating these three pillars, we can easily achieve our sustainable practice in our construction field. These are the four phases we are using here. First one, we have to input. Second one, transformation. And the third one is that is output. And the fourth phase is a catalytic. So first one, identifying the raw materials. Second one, we are going the transformation. I already said the raw material should be decomposed by mechanical or chemical or thermal engineering. The third thing, we have to go for the these things should be converted to the raw materials. And fourth one is the main thing. it is termed as a softer one, because these materials should be converted to product and also our financial policies. So this is the first one phase. Just we are collecting the raw waste streams, and we are categorizing. First one, see there are different types of, whether it is a plastic one or it is a raw materials or it is a greeny cabbage. We have to segregate the waste products. Second one, so based on the waste products, whether we have to treat it with mechanically or it should be treated with chemically or it should be treated with thermally. So based on that, the product should be distributed for the production of materials. So this is the process materials which is integrated directly to the structural elements. So my raw materials now it's converting to a fly aspect like, or otherwise it should be become as a channel sections, or it should be a for modular sections or any frame structures. My raw materials is directly converted as a materials as per the engineering properties. So this is the valorization matrix. I already said that valorization is nothing but we are converting the waste into the wealth product. So here first the linear waste disposal, we are using fully integrated material reuse. Then high disposal and sourcing water. For example, we are using the plastic water cans or plastic bottles. Here automatically it will converted for the road. That is lowered holistic life cycle cost. Third one, regulatory liability and risk. So we have to meet the regulatory demands. I already said it is the fourth one is a much more important software. So we have to provide some standard code books for this. So this is the fourth process. We need both the policies and also the economics. Without these two, our product should not be in the market. We have to maintain the standards and we have to follow their policies, and also it should be adaptable to the market value. So this is the framework for the modern sustainable construction. First of all, I have to categorize what are the waste streams. Then I have to apply in the engineering streams with the different process, mechanical, chemical, and thermal process. Then I have to go for the circular economic. So what are the strategies for reducing the construction environmental, this carbon footprint is? First, I have to design well, then materials checking, then it should be go for on-siting, then it is a operational retrofitting. See, first one, it is a present building in the environment. Mostly we are using here steel framing is used. While steel framing is automatically the embodied energy, that is embodied carbon steels is automatically we are producing 15 percentage, and after it is be installed it will convert to 83 percentage. Totally it starts carbon emission of 23 to 40 percentage of carbon emission in the greenhouse effect. So by this traditional building, I have converted a few. So here I used a foundation instead of Portland cement. I am going for fly ash or slag concrete mixes. Automatically it reduced 45 percentage of carbon dioxide reductions. Second one, we have seen that it is a steel I beams. We can go for the mass timbers or the recycled materials, or we can go for the bamboo also. The third one, it is insulation materials. This insulation materials is automatically transferred to hempcrete. Now the hempcrete concrete is very much famous, and also it is adapted little by little in our building construction process. So this is a short thing we are making. So instead of traditional concrete, we can go for the geopolymer. Automatically, high reduction should be found in the embodied carbon. Then steel, because steel and cement are the major products for the carbon emission in the construction materials. So instead of steel, we can go for the mass timber, or we can go for a bamboo. Then traditional insulation, we can go for hempcrete, and for finally we can use for the any recyclable or bio-based materials for the substitution of structural and this finishing materials. Nowadays we are just throwing the construction debris. It will be recycled and it will be used as a recycle as a aggregate one in the construction, new construction building. It is a landfill material. Now it is used for a reused aggregates. Then industrial byproducts like fly ash we are using for the cementinous materials. It will enhance our performance of the concrete and also building. Then agriculture residues we are using as a insulation material. So each waste materials is automatically converted to a wealthy materials in the construction field. Not only it's for circular economic, it also for our sustainability, the mechanical, we are using the bio-based material. That is, we are in engineering, they called us pyrolysis method. They're converting the biodegradable materials into a usable material. Second one, the chemical stabilizations, mostly the contaminations and also the great alcoholic process should be taken from the chemical stabilization. Third one is a thermal conversion. Well, the already said it's a pyrolysis or gasification, which means when we are using agri-based materials, automatically it consists of some biodegradable characteristics. That means in future, it will be converted to fungus attacks when we are using directly. If you are going for pyrolysis method, automatically these biodegradable materials get degraded and automatically it will fulfill all our things in the concrete. Cement, we can use go for the fly ash. Instead of insulation materials, we can go for the agriculture based one. Then instead of steel, we can go for the timber one. So this is the traditional one, that is take, make, and dispose. Okay, so this is the
Mm.
first concept we are using at present now. But in our sustainable material, that is 3R, that is recover, recycle, and reuse. These 3R will make a great impact on our environment. So this is the difference I have said that while demolishing, automatically the demolished structure should be in the landfill. But here, what we are doing, just filling of the by using the modular panels, we automatically just make
Mhm.
a bolt on that or welder on that. If you have to dismantle means immediately we can remove from the building, so there should not be any landfill materials there. Actually, the sustainable materials adaptation is very complicated because no one will accept it. Because when any person is going to build a construction, they preferably will go for the cement. When I going to even academicians, or even I am a inventor, or I am a civil engineer, when I approach a consultant or any building person, so instead of cement, we can go for 40% of fly ash. No one will accept it. Okay, so it is a great problem in our,
That's true.
yeah, it's a great one we are facing in the environment. But we have to. That's why I say we have to use some standard stand code books. So this will make them, will assure them, okay, we can go for the some sustainable materials. So it is a not immediate process. We will achieve it. It will take nearly 40 to 50 years to achieve this sustainable construction buildings. Because now only we are talking for the past 10 to 15 years only we are just focusing on the sustainable materials. So year by year it
Yeah.
automatically increases. First we have to execute the sustainable process, then we have go for the material substitution. Now only we are reaching the material substitution impact. So this should be automatically go for the circular site operation, that is circular economy. That's why after after achieving all this only, we will go for the end life. That means we will avoid the 40 to 50% of global that is carbon emission in the construction building. But it will takes a little bit time, but it will be a achievable one. So how it will be achievable? So main problem is in our market. So first I say we have the standards and certifications, because without standard and certification, no one will get ready to accept our product. So this standard and certification will automatically impacts in two areas, that is in the market incentives and also the economics. Because when the product is going for cement, they are purchasing for 600 rupees. Sir, my fly ash, my concept is totally different. Then only for rupees 400 rupees per bag they will get nearly 200 rupees, getting profitable. So it will be give a is a life cycle cost analysis. It will give a great economical building, and also we will assure that, sir, it will be a very good achievable strength and durability than the traditional concrete. So the regulation should be based on the market incentives and also the economic. So first we have to material resources, then transform engine, then build application. These things it will be easily achievable by anyone. But the final thing, that's market demand. It is a great one, and we have to still focus on the market demand to achieve our sustainable products in the market to become a circular economy. I already say
Mm.
that. the transferring environmental liability into structure. So these things are the much more important. Now the certification is based on the three things that Beam, SQL, and Lead. They are ready to give the certification and the guidelines for using our sustainable materials. We have to go and still approaching of them. At more or less, we are waiting for getting a sustainable core practices books for all over the world, and this thing guidance should be done by these three things. I am just reaching out my end position. That is, environmental reduction is not a design trend. It is a systematic engineered process. So each and everything we have to get systematically. We have to analyze the raw materials, whether this raw materials should be replaced for the traditional one, while replacing whether it should be reduce our greenhouse and also the carbon content. This all the things should be mainly focused on the strength and durability of the of any building. So the strength and durability should not affected by the sustainable materials. And so this is not a design one; it is a systematic engineer process. My presentation.
Thank you so much, Dr. Murugesh. It was such a refreshing one because I just know the basics, but the big process behind this, it carries a lot of structuring, engineering, the model, the regeneration, rethinking. So you have explained us in a very easy way so that everyone who is watching and listening, they can easily understand, even by watching or by listening. So thank you so much for that, a very understandable and easy, simple presentation, I would say. It takes a lot to make it simpler because if I am not from my engineering background, understanding all these technical terms will be very hard for me. You made it very simple and easy for us, so thank you so much for that. When you approached civil engineers or who is doing construction works or anyone, when you try to talk to them regarding these eco concretes or eco things, fly ash, the first thing they ask is like, what is the cost, what is the durability, right? So that's question, of course. Even the person like me, when I'm a researcher, I'm an environmentalist, when I talk to these kind of people, I hear this question and they ask me, can you give me the guarantee, these are the new materials, we don't know, we want to stick with the traditional method. We can give them something like what it could be, like how do these alternative materials compare with the construction materials in terms of strength, durability, and cost? What would you say?
Yeah, it's a very quite interesting question for me also. Yeah, it is. For just I give a small example. I have prepared a carbon capture bricks with the help of our JCT college management. We have prepared carbon capture brick instead of traditional brick. The brick is look like same as a traditional concrete. What I have done means when I have go for a social marketing impact, I said, sir, our traditional that is traditional brick should carry 7.5 Newton per mm square crushing strength. Okay, so see, just check out my carbon capture bill. It normally comes around, it's nearly 10.75 Newton per mm square. So automatically the strength, first the strength concept is increased. Second one, I said, sir, just check out the weight of the brick. It's more or less both are in the same. Okay, what is the cost? Again, this they came to the concept. Okay, they are satisfied. Okay, strength wise, we are okay, sir. What about the durability? They asked. So for water absorption, we are used to for 24 hours. Here, 10 percentage only maximum limit for permissible limit for water absorption. For normal traditional big, I got is nearly 5 to 6%, but here 2 to 3%. Immediately, the person asked, how it happened? Yes, I already said I'm using biochar. This is a carbon capture brick. I'm using the biochar. This biochar will fulfill all the pores inside the bricks. Once all the pores is totally fulfilled means when no water can persist inside the brick, automatically water absorption will be increases. I got just 3 to 4% when comparing to normal. Okay, immediately okay. So as per the engineering property, you have very good strength and very good. Next, as our human mindset, sir, what about the cost? I say the cost of the traditional bricks. Yes, the cost of the traditional brick is nearly at present is 9. But my carbon capture bricks is nearly 6.5 rupees. That is 6 rupees 50 paise. So it's nearly 2.5 amount should be decreases from the traditional one. Then he say how it will be happen. So simple. I'm using the biochar. It's a waste material. I just converted the waste material into a wealth material. So I will achieve the strength, I will achieve the durability, and also I will achieve it in the cost also. Then only as from the experimental view, then as per the cost analysis view only, the any person will accept our product. So we have to show the engineering properties with them. That's why I say that we have to implement the guidance, that is code books for this sustainable practice.
That is a beautiful explanation. Thank you so much for that. Because what I also experienced in the field is same. People are using this silica plastics and the compressed plastics on the waste materials. Usually, the question that I ask them, because I didn't got an answer for it, sir, if you are using a recycled material rather than the sourced material, our cost should be less. That is the whole core process. Where a lot of people will like, no, it cannot happen. And now you gave me a proper answer which satisfy me 100%. All our viewers and everybody listening there, they want to reach out to you and they want to know about it. So if that is the case, what is the way to reach out? Is it the only social media, or you have any website, or how come?
It should be actually the outcome should be from the social media only, first of all.
So thank you so much, sir. So if viewers, if you are watching or listening, reach out to sir. He's the right person if you are going for a proper good eco concrete. He gave all the proper demonstration, so go for it. And I have one more question, sir. Like, what are the biggest challenges, a technical, economic, or even a policy related, in scaling waste to construction solutions in country like India?
Oh, in India, yeah, yeah.
Yeah,
First one we have to
I know,
vary.
I know.
Yeah, first one we have for the waste should be variable one. We have to collect the different types of waste materials. Second one, it's we have to test the materials whether it should be for going for long term durability, because we are going for replacing traditional one in the construction field. So first one I am facing, it's we have to check whether it is proper material segregation for the corresponding for the term strength and durability. So this one we have to first we have to identification of the product. First one I am facing this problem. Second one is a lagging of code books, because yeah, after all the process we are very much lagging in the code books. Without code books you should not be go for the market. So this is the second thing I have facing. Then third one, like IS, like Indian standard or ISO, like BSA standard. These things should be provide for the sustainable construction material, because anyone preferred, okay sir, so this is ISO material, it is a BA material, means no one will ask any questions directly. They will,
Questions.
yeah, they will buy or they will purchase our material. So this regularity we are facing problems, but I hope it will be resolved as soon as possible, because now only many one have a awareness of the sustainable materials, and also the government side, it will be very much helpful for us to provide these code books and also the standard based standards for the sustainable materials.
As we wrap up, one thing is clear: sustainability is no longer just about reducing harm, or it's about redesigning the way we build, we live, and we think. Turning waste into wealth is just not an idea, it's a responsibility, and more importantly, an opportunity. So big thank you to you, Dr. Murugesh, for sharing such a valuable insights with us today. And more importantly, these methods all are grassroots. So thank you so much for giving back to us. So in this, if the conversation sparked a new perspective for you, don't keep it to yourself. Share this episode with someone in the engineering, in sustainability, and someone who can design the policy. And if you're someone who believes in creating impact driven conversations, make sure you follow the sustainability side, and also Dr. Murugesh, so that he can give you amazing ideas and all the informations regarding this eco concretes and all the construction related waste, all this kind of things, he's the one to go to person. So approach him. And you can of course listen to the sustainability side on your favorite platforms like YouTube, Spotify, Apple Podcasts, and everywhere. And at the end of the day, as I always mention, sustainability is not mine and it's ours. Because here we just don't talk sustainability, we build it. And let us build together. So until next time, stay tuned, curious, and safe only with the sustainability side.
Feel the joy, let's unite on the sustainability side. Making waves, shining light. From city streets to the open skies, together we rise with a love that defies.